When your project demands more than just a standard data acquisition tool, you need a flagship. Welcome to the next level of open source instrumentation, the STEMlab 125-14 PRO Z7020 Gen 2. Whether you are stabilizing lasers in quantum experiments, pushing the boundaries of magical imaging, or building mission-critical aerospace system, the original hardware was just the beginning. Today, we are diving into a board that maintains the same compact footprint while delivering a massive leap in processing power and versatility. This is the PRO Z7020 Gen 2 evolution of the Red Pitaya ecosystem, and it's engineered to be the brain of your most demanding applications.
The STEMlab 125-14 PRO Z720 Gen 2 is the flagship model of the Gen 2 series, engineered for use in industrial automation and test and measurement. The most demanding application list: quantum computing experiments, photonic applications, medical imaging technologies, space applications, and advanced OEM solutions. While it shares the original unit's compact form factor, it represents a significant leap in versatility and processing power. The core differentiator is the Xilinx Zynq-7020 SoC. The Zynq-7020 variant provides a larger FPGA fabric, which is necessary for handling more complex real-time signal processing and custom logic that the Zynq-7010 cannot support. The Zynq-7000 family combines a dual-core ARM Cortex-A9 processor with Xilinx 7 series programmable logic. While the CPU remains the same across both models, the FPGA fabric is significantly expanded in the Xilinx 7020 model. The Zynq 7020 has roughly 3 times the logic capacity of the Zynq 7010. With nearly triple the number of DSP slices, the Zynq 7020 can handle much more demanding digital signal processing tasks, such as high-order filters or multi-channel FFTs. The increased block RAM in the Zynq 7020 enables larger internal data buffers and lookup tables, reducing the need to access external DDR3 RAM for high-speed logic operations frequently. To support the larger FPGA fabric, the Z7020 Gen 2 model features 1 GB of DDR3 RAM. Sheet 8 of the schematic details the Bank 502 DDR3 controller, which provides the high bandwidth 16-bit interface required for the Zynq 7020's intensive buffers. The board features a redesigned analog front-end for ultra-low noise performance. The ADC for the RF inputs is the LTC2145 CAP14, a 14-bit 125 megasamples/second dual ADC. It supports plus or minus 1 volt in low voltage and plus or minus 20 volt in high voltage full-scale ranges, with absolute maximum input protection of plus or minus 30 volt in HV mode. The main ADC and FPGA clock signal can be supplied from an external source through the external ADC clock ports on the E2 connector. Both the internal oscillator clock and the external clock signal are connected to the NB6L72 differential crosspoint switch. The clock cell pin 21 on E2 connector is used to select the clock source. The RF outputs employ the AD9767 ASTZ, a high-speed dual-port 14-bit DAC. It delivers signals up to 50 MHz bandwidth at 125 megasamples/second with the voltage range of plus or minus 1 volt to the 50 ohm load or plus or minus 2 volts to the high impedance load. The Z7020 model offers the most flexible I/O configuration in the lineup. E1 connector features an expanded count of 22 digital GPIOs, up from 16 on other models, operating at 3.3 volt logic, and contains a CAN bus interface. E2 connector provides 4 slow 12-bit ADCs with 100 kilosamples/second and 4 slow DACs constructed using 8-bit PWM channels with about 3.2 megasamples per second sample rate. The E2 connector pins out SPI, UART and I2C interfaces. The Z7020 Gen 2 model is the only variant supporting the E3 connector with 8 fast differential pairs totaling 16 high-speed GPIOs directly connected to the Zynq-7020 FPGA. Think of the E3 connector as a modular docking station for a spaceship. The high-speed pairs are like the main data cords that plug directly into the ship's brain for instant reaction. For mission-critical reliability, the board is compatible with the QSPI eMMC module Gen 2, which plugs into the E3 connector. The QSPI eMMC module is powered by an onboard STM32 microcontroller. The module enables single-button powering and safe shutdown via the P-on button. The board shuts down after a 1-second hold on the P-on. If you hold the P-on button longer than 5 seconds, it triggers an immediate power-off. Other features include watchdog recovery and booting from highly reliable eMMC and QSPI flash memories. The board supports multi-channel synchronization via the S1 and S2 USB Type-C connectors. These connectors enable clock and trigger synchronization between boards, as well as an optional high-speed link to exchange data between the boards. These ports provide a dedicated serial link up to 500 megabits per second for interconnecting multiple Red Pitaya modules. Note that these connectors are not compliant with the USB Type-C standard and should only be used to connect Red Pitaya devices. What might surprise you is that there are more ways to sync more Red Pitaya units. One of them is Click Shield. The Red Pitaya Click Shield extension module enables users to extend Red Pitaya hardware with 2 micro-E clickboard and power them from either an external USB power adapter or a 12 to 24 volt external power supply. Using UFL patch cables, the shield can be utilized for the mentioned high-performance clock and trigger synchronization between multiple Red Pitaya units and other devices. The STEMlab 125-14 PRO Z7020 Gen 2 stands as the ultimate flagship of the Red Pitaya ecosystem. The Xilinx Zynq-7020 SoC offers a significantly larger FPGA fabric and triple the logic capacity of the standard Zynq-7010 models. To support this massive processing power, the STEMlab 125-14 PRO Z7020 Gen 2 model features 1 GB of DDR3 RAM. S1 and S2 daisy chain ports provide a scalable platform for scientific and industrial innovation. If the standard Gen 2 is a high-performance laboratory, the Zynq-7020 Pro Gen 2 is a massive research facility. A larger Zynq-7020 SoC, twice the RAM size of 1 GB, high-speed E3 port and daisy chaining USB Type-C ports. With the dedicated security and power module, the QSPI eMMC module runs perfectly 24/7. It has to be noted that Gen 2 boards are backwards compatible. This means that custom applications and projects created by the community for original generation boards, like laser lock-in photonics applications, projects Pi, RPL and Linean, SDR applications, VNA, multi-channel pulse height analyzer and others directly work on Gen 2 boards without modification.
With full backward compatibility for legendary community projects like Pi, RPL and Linean, you can upgrade your hardware without rewriting your history. Ready to scale your imagination? The STEMlab 125-14 PRO Z7020 Gen 2 is ready for 24/7 mission critical duty. Thanks for watching, and I can't wait to see what you build next.